Hello, welcome back to the Elements of Civil Engineering and Mechanics class. So yesterday we solved a problem. In this class, let us solve one more problem. So almost along the same line. So the problem goes like this. 4 coplanar forces acting at a point are shown in figure one of the forces is unknown and its magnitude is shown as P. The resultant has a magnitude of 500 Newton and is acting along the x-axis. Determine the unknown force P and its inclination with x-axis. So the problem goes like this. Sorry, 200 Newton. This is 45 degree. This is 500 Newton acting at an angle of 30 degree. This is 200 Newton acting downwards. And here is the resultant R of magnitude 500 Newton acting towards right, and there is an unknown force P, and the inclination of the unknown force is theta with respect to the x-axis, and the angle is measured in the clockwise direction. So here what we need to do is, we need to find out what is the value of P, that is the unknown force P, and what is the angle theta at which the unknown force P is inclined. So this is the problem as given. First what I do is, I am going to split up the figure. Just I am going to keep all the forces on one side, and I am going to equate that force to the resultant, whose value is given as 500 Newton. So this is the way it goes. This is x-axis, y-axis. This is 200 Newton. Okay, this is acting at an angle of 45 degree. This is unknown force P. This is theta, 500 Newton. This is 30 degree, and this is 200 Newton acting vertically downwards. So these are the forces, 4 coplanar forces that can be equated to the resultant. This is x, y-axis, and this is the resultant R, that is equal to 500 Newton. So I am going to make this yellow chalk piece. (500 Newton). So what I do is I am going to resolve all the forces in the x-axis and the y-axis, and I am going to add them algebraically. So a sigma fx is the algebraic sum of all the forces in the x direction. I am going to equate that to the horizontal component of the resultant. Then sigma Fy, that is the algebraic sum of components of all the forces in the y direction. So I am going to equate that to the vertical component of the resultant. Why I say the horizontal component of the resultant and the vertical component of the resultant? Here, for example, if I assume for a moment this resultant is acting at certain angle, so the resultant should also be resolved in the horizontal and in the vertical direction. Then algebraic sum in the x direction should be equated to the horizontal component of the resultant, and algebraic sum of the forces in the y direction should be equated to the vertical component of the resultant. So in this case the resultant is acting horizontally. So that sigma fx, that is algebraic sum of the components of all the forces in the x direction, should be equated to the resultant. As far as sigma Fy is concerned, that should be equated to 0 because this resultant does not have a vertical component. So those are the steps I am going to do to solve this problem. So to start with, let us resolve the forces horizontally and vertically. So again here I can equate this to this. So what is the horizontal component of 200 Newton? So that is 200 cos 45. So this is acting to the right because the tail end of the arrow is attached. Keep it fixed, move the head not more than 90 degree until the force becomes horizontal. So whatever the direction the arrow points to, that is to the right, you must show here. Similarly, for the vertical component, like this, so the arrow points upwards and the component in the vertical direction is 200 sin 45, cos 45 because this component is adjacent to the angle 45 degree. Sin 45 because it is away from the angle 45 degree. So this is resolved. Next, coming to this, Yes, this force is acting away from the center, that is origin, and the angle is measured with respect to the horizontal axis, and it is measured in the clockwise direction. So vertical component is P sin theta, and the horizontal component is P cos theta, Next, there is another force here, that is 500 horizontal component. So if you rotate like this with tail end fixed, so the arrow is pointing to the left. It is 500 cos 30, and the vertical component is 500 sin 30. Okay. Next, there is already this 200 Newton acting downwards. So I am going to use a different chalk base. It is 200 Newton acting downwards. So this does not have a horizontal component. Okay, now all the four forces are resolved. So that should be equated to R equal to 500 Newton. Okay. So vertical component, yes, it is 0. So as I said, if this had inclined at certain angle, I would have resolved the resultant into horizontal and vertical components. Now what I do is, I am going to take sigma fx and I am going to equate that to the resultant. Next, sigma fy, that should be equated to 0. So we will have two equations and we have two unknowns. Two equations, two unknowns, solve for the unknowns. So let us start with sigma fx, that is sigma fx equal to, that is the algebraic sum of the horizontal components of all the forces, sigma fx on this side, that should be equated to the resultant R. Okay. So R I am going to write. See, it is plus R. The reason is R is acting to the right. If R was acting to the left, I would have put minus R here. So here I am going to take the value as it is with plus sign because it is acting to the right. So let us go with sigma fx. So what are the sigma fx we have? We have 500 cos 30. So 500 cos 30. What is the sign? This force is acting to the left. So according to our sign convention, it is minus sign. Again, P cos theta acting to the left, that is minus P cos theta. Is there any other horizontal force we have? Of course we have this. So it is 200 cos 45 with plus sign, plus because this is acting towards right. That should be equated to R. What is the value of R? The value of R is 500 Newton. Okay. Here, finally, P cos theta equal to, 1 second, minus 500 cos 30, not theta, this is cos 30. Finally, P cos theta equal to minus 791.59. So let me call this equation 1. Similarly, we have sigma Fy equal to, that is algebraic sum of all the forces in the vertical direction. So that should be equated to, what is the vertical component here? It is 0. So I am going to equate this to 0. So what is sigma Fy? That is P sine theta acting upwards, that is P sine theta. Next 200 sine 45. 200 sine 45. If you look here, this is acting downwards, minus 500 sine 30, and this is minus 200 because it is acting downwards. Finally, that should be equated to 0. So that is 0. On further simplification, so I am going to get this as P sine theta equal to 308.58. So I am going to call this equation 2. So we have two equations, equation 1 and equation 2. I am going to divide one equation by the other. So I am going to divide equation 2 by equation 1. So I am going to get P sine theta divided by P cos theta, that is equal to 308.58 minus 791.59. So PP get cancelled. So tan theta equal to minus 0.3898. Therefore, theta equal to minus of 21.39 degree. So it is not 39, sorry, 30 degree. 21.30 degree. That is the value of angle theta. Now, by knowing theta, we can find out the value of P by substituting the value of theta in equation 1 or equation 2. So by substituting, the value of theta in equation 1 or in equation 2, we get P equal to minus 849.63 Newton. That is the value of P, and this is the value of theta. So these two values we got as negative. So what is the meaning of it? How do you show how the force is acting? So if you look here, P is acting away from the center. Next, the angle is measured in the clockwise sense. Because we got this value as negative, instead of measuring in the clockwise sense, what I am going to do is, I am going to measure in the anti-clockwise sense, because I got the value as negative. So it is P, it is theta is 21.30 degree. Next, so what is the value of P? That is minus 849.63 Newton minus. That means whatever the initial direction given in the problem was not correct. So this direction is acting away from the center. Because we got the negative value, the direction should be changed. Means that force should be acting towards the center. Therefore, P equal to 849.63 Newton. Okay, the values we got as negative both. So when you draw this figure to show the final result, once you change the direction, so you don't have to show minus 21.30 degree or and minus 849, no. So the directions are corrected now. So simply show the numerical values of theta and P. So this should be your final answer when you express it. I hope this is clear. So let us go with the next problem. The problem goes like this. A force F1 equal to 1200 Newton is acting vertically on an incline. On an incline is nothing but this incline. This is a plane, inclined plane, which is making certain angle with respect to the horizontal. Okay. So find its components along x and y axis. So that means we need to resolve this force along x and y directions. So before resolving, we need to know what are the angles. So you can find out what is this angle, or we can find out what is this angle. One of those two angles. If you find out, the problem is over. So once, say, if this is some angle, then f of cos 30 is the horizontal, is the component along x direction, and f of sin 30 is the vertical, sine angle is the vertical component. So in this case, x and y axis are not horizontal and vertical. No. Those axes are taken along the plane and across the plane. That's fine. So reference axis not necessarily always horizontal and vertical. So of course this is parallel to x, this plane, and perpendicular to this plane. Okay. So first we will find out what is the angle. So before starting any angle, just I am going to remind you of basic geometry of high school. These two are parallel lines. If I draw a line that cuts these two parallel lines, if I call this angle as theta, okay, and this angle should be theta because these two are alternate angles. If this is theta, this should be equal to theta because these two are vertically opposite angles. And if this is theta, this should be theta as well because these two are corresponding angles. So I am going to make use of this here. So before going further, so what I do is I am going to find out what is the angle. If I call this as theta, theta is the angle the plane makes with respect to the horizontal here. So if I call this as theta, this should be theta because this line is parallel to this and this is the line cutting those two parallel lines. So these two are corresponding angles. If I call this as theta, of course that should be theta. So we can find out what is angle theta in this triangle. That is, if I take that triangle, okay, this is 3 and this is 4. I hope this is visible. So I am going to complete this triangle. This is a right angle triangle. By applying Pythagoras theorem, this is square root of 3 square plus 4 square. That is equal to square root of 25, that becomes 5. So of course this angle is theta. We have called this as angle theta from here. So once we know this, we can find out what is theta. Tan theta equal to 3 by 4, that is 0.75. Therefore theta equal to, if you find out using a calculator, you are going to get 36.87 degree. Or what you can do is, because we are using only sin theta cos theta, you can directly find out what is sin theta and what is cos theta from this triangle. So from this triangle, what is sin theta? Sin theta is opposite side by hypotenuse, that is 3 by 5, that is equal to 0.60. And what is cos theta? Cos theta is adjacent side by hypotenuse, 4 by 5, that is equal to 0.80. So I am going to make use of these two values directly. In other words, find out what is angle theta. As I said, that is going to be 36.869 something. So we are going to round off that to nearest second digit, then we are going to get 36.87 degree. So both ways you can do. So let us come back to this. This is the problem given. So next what I do is, in the given problem, I am going to write another figure. Okay, this is the plane. This is theta. And this is the force 1200 Newton acting downwards. Okay. And this is x-axis and this is y-axis. So at this point what I do is I am going to draw a horizontal line So once I draw this horizontal line, this line, okay, cuts, this yellow line cuts these two parallel lines. This is parallel to this horizontal line. And if I extend this back, if this is theta, this is also theta. So when this is theta, this should be theta as well, because they are corresponding angles. Okay. Now we know angle theta, because from here. So I need the horizontal component. So horizontal component of this force is, here the head is fixed, move the tail like this, and the arrow points downwards on the horizontal, and the component along the x-axis will be 1200 cos of angle theta. Similarly, if you move this tail perpendicular to this plane, that is along y-axis, the arrow points downwards. So the vertical component is, or sorry, not the vertical component, the component along y direction is 1200 sine of theta, because the vertical component is away from the angle theta, that's why it is sine. So you know what is the value of cos theta? You know what is the value of sine theta? Directly substitute those values. And we are going to get the vertical component of the force F and the, I keep saying vertical component. The component of the force F along y-axis, and also I am going to get the component of the force along the x-axis. So from figure, so component of the force along x-axis, I am going to call that as Fx, F cos theta. Okay. So what is the value of F? That is 1200. What is the value of cos theta? Cos theta is 0.8. That is 0.80. That is equal to 720 Newton. Okay. And what is the inclination of the component? That component force is making an angle of theta with respect to the horizontal here. Be careful. So I resolve the force along the x-axis. The magnitude of that force is 720 Newton. And we need to know at what angle that is inclined with certain reference line. Here I am making the horizontal line as reference. So what is the angle? That is theta. So here the value of angle theta is 36.87 degree. So I am going to write this as 36.87 degree. So this should be your final answer. As far as Fx is concerned. Similarly, Fy equal to 1200 sine of angle theta. What is sine theta? It is 0.6. That is equal to 1200 into 0.60, and Fy equal to 960 Newton. This is 960, not 720. This is 720 Newton. 720 Newton. Okay, what is the angle at which it is acting? So you can reference the angle with respect to the horizontal or with respect to the vertical. So if you take this, and this angle will be how much? 90 minus of theta. Okay, so that is 90 minus of theta is 90 minus of 36.87, that is equal to 53.13 degree. That is the vertical component of the force 1200 is Fy, and it is making an angle of how much? It is 53.13 degree with respect to the vertical line. It is not the y-axis, with respect to the vertical line. So what is Fy? Fy is 720 Newton. So this should be your final answer. I hope this problem is clear to you. So I'm going to take care of another problem along the same line, but instead of resolving the force along x and y axis, so we have made the x and y axis as horizontal and vertical, and we are going to find out what are the components of those forces along those two directions. So let me go with the next problem. If you followed this, the next problem would not be so difficult. The next problem goes like this. A force 200 Newton is acting as shown in figure. As shown in figure. Find the components of forces along horizontal and vertical axis. So ignore friction between contact surfaces. And so there is a little bit of correction here. See, a force 200 Newton is acting as shown in figure. Find the components of forces along horizontal and vertical axis. Ignore friction between contact surfaces. As of now, you don't worry about what is the meaning of the friction between contact surfaces. We are going to take care of this friction part in this course, so in the subsequent modules. So this is the problem given, and there is a weight or there is a block of certain weight. Okay, ignore that weight and ignore the friction. This is a plane, and this plane is inclined at an angle of 30 degree, and we have put this weight. Okay, then there is a force acting at the center of the weight or center of gravity of the weight of magnitude 200 Newton. And this force 200 Newton is at an angle of 30 degree with respect to the line which is parallel to this inclined surface. So we need to find out what is the component of this force not along this inclined plane, instead it should be what is the component of this force along this line, that is along the x-axis, and what is the component of this force along the y-axis. That's what we need to find out. So if you look at the problem, so in the previous problem we resolved this force, resolved the given force along this axis and along this axis by calling this axis as x and this axis as y in the previous problem. Here we have called this as x and y axis, both, that is horizontal and vertical axis. So to resolve this force, as I said, I need to know the inclination of this force with respect to the reference axis. What are those reference axes? X axis and y axis. Okay, here it is 30 degree. We need to find out what is this angle. So if you look at this, this is parallel to this and this is parallel to this. This is parallel to this and this is parallel to this. When this is 30 degree, this should be 30 degree as well. Is it not? So just to explain it simply, if I have two lines, okay, so if I call this as theta, take a copy, the original remains as it is. Take these two lines, a copy of these two lines, and I am going to place this somewhere here. So if I place a copy of these two lines somewhere here, exact Xerox copy of these two lines. So if this is theta, this remains theta, and this is parallel to this, and this is parallel to this. Similarly, if I take another copy of this, if I turn this 90 degree, so that line becomes, those two lines become like this becomes vertical, and this line becomes like this. So what is this angle? Again, this is angle theta. So what it means, angle between any two sides is equal to the angle between their parallels. There means here, these two parallels, their parallels and their perpendiculars. So if you keep this concept, it is going to help you in solving the problem. Next, coming back to that problem. We know this is 30, this is 30. So what is the angle the force makes with respect to the horizontal? That is 60 degree. Once we know this angle, so 200 cos 60 acting to the left is the horizontal component, 200 sin 60 acting downwards is the vertical component of the force 200 Newton. I hope this is clear. Let me solve this problem. Horizontal component Fx equal to 200 cos 60, that is equal to 200 into 0.50, that is Fx equal to 300 Newton. Okay, with minus sign. So cos 60, 200 cos 60, and again it is 200 cos 60, 200 multiplied by 0.5. Okay, and what is the sign? I am going to put minus sign because the horizontal component of this 200 is acting to the left. So that is equal to minus 100 Newton. That means Fx equal to 100 Newton. Means the force should be, that is the component force should be acting to the left. And similarly, vertical component Fy equal to 200 sin 60, 200 sin 60. This is fixed, move the tail and it becomes vertical acting downwards. According to our sign convention, any force acting downwards as negative. So sin because this vertical component is away from the angle theta. So that is equal to minus 172.2 Newton. That is nothing but Fy equal to 173.2 Newton. Minus means acting vertically downwards. I hope this problem is clear to you. So I am going to end this class and I am going to do some more problems in the next class. Thank you.